similar triangles here. Okay, we know they're similar triangles because they told us that the angles are all the same. They use these symbols here to represent them. They could have given us numbers, but what they're saying is this symbol is the same as this symbol is the same as this, and this x is the same as this. Okay, but what we do know is our lengths are definitely different, right? We kind of have to figure out what corresponds with what. So our 12 centimeters is between these two angles, which means our 7 centimeter is the one that corresponds to that side. Our 7 centimeters here corresponds to this side, and our 8 centimeters corresponds to this side. And it's all set up the same, so it's pretty simple to see. What we need to find is some kind of scale factor. So when we're moving between these values, okay, if we're moving from the smaller to the larger triangle, we are multiplying, okay, by whatever the scale factor is. If we're moving from the big triangle to the small triangle, we're dividing by whatever the scale factor is. And the reason being, if you think of it, we have to go from small to big, therefore we multiply, we grow larger, and to go from big to small, we divide to get smaller, okay? Now to figure out what the scale factor is, we just actually take the values and divide them, okay? If I divide the 12 by the 7, that will tell us what we're going to multiply to. We'll divide the bigger one by the smaller one. So 12 divided by 7, and we can go to our calculator to find out what it is. 12 divided 7 might be repeating. Now it's a very long repeating value. So instead, I know this isn't simple for you, I'm actually going to leave it as 12 over 7. So think of it like we're multiplying by 12 over 7. Yeah. Which means I'm dividing by 12 over 7 if I'm shrinking, okay? So since we're going from the big values to the small values, we are dividing. I'm going to take this 8, and to figure out what this side is, I need to do 8 divided by 12 over 7. So I've got to divide by a fraction, okay? Probably not the nicest thing. Same idea here. To figure out the 7, I got to take 7 and divide by 12 over 7. So we've got to remember our division of fractions, okay? So 8, so our first side, divided by 12 over 7. Well, think of 8 as a fraction itself, okay? It'd be 8 over 1. And when we divide fractions, we actually invert and multiply. I don't know if you remember that idea. We turn it to a multiplication, and we invert the second fraction, which becomes 7 over 12. So then we just multiply across the top by the top and the bottom by the bottom. 8 times 7 is 56 over 12. So whatever that is our measurement of the one side. And we'll do the same thing with the number 7. 7 divided by 12 over 7, okay, ends up becoming, think of it like 7 over 1. 7 over 1 times the inversion of this, which is 7 over 12. That equals 49, 7 by 7 over 12. So we can find out our decimal values. Fractions are technically correct. 56 divide 12. 4.6 repeated, so we'll say approximately 4.7-ish, okay? And 49 divide 12, 4.08, we'll say approximately 4.08. So 4.7 for this side, and 4.08 centimeters. Now this was a really hard example because I chose to work with everything in fractions. You could have just put the scale factor as a decimal and then just divided by that decimal and gotten really, really close. So for instance, if you recall, our decimal was 12 divided by 7. I didn't want to write that decimal in. Well, let's say we rounded it. It was 1.71, let's say. Zoom back in. Instead of doing all that fractional work, I could have taken 8 and just divided by 1.71. I think that we said that was the value. 8 divide 1.71. Okay, so I could have divided by this because it kept in my calculator, but I'll do what I rounded by. And we get 4.67, which is really close to that. And if we did the same with the number 7, 7 divided by 1.71, we get 4.09, which is really close to that. So if it's just easier to divide by that scale factor, then just divide by it. If you want to be super exact, then you can use your fraction and get fractional answers too.